So let's go see how we use these two classes in our code. The first thing we do on line 9 is include our classes with a call to require once and the name of the file interfaces.php. Then on line 11 we create a new object of type movie catalog, and we assign that to a variable called movies. On line 13, we create a new movie object. We pass the 4 arguments that the constructor for movie requires: the title, the director, the year, and the rating. Then on line 15, we call the insert movie function of the movie catalog object and pass it the movie object we just created. So that's our first array element in our movie catalog. On line 17, we unset the M1 variable to which we assign the new movie object. On line 19 through 23, we demonstrate a shortcut for creating a movie object and inserting it into the movie catalog in one line of code by creating the movie object within the call to insert movie. There's no reason to create a local variable and then pass that local variable to insert movie, because the array in the movie catalog is going to hold a reference to this newly created object of type movie. This code does not need to hold a reference to the object, because that reference is being held, again, by the array in the movie catalog object. We do the same thing on line 21 and 23 with 2 other new movie objects. And notice how we've played with the case. Now, a quirk with the UCWords function, and we'll go back to our code here in the constructor on line 85 and 86, of the movie class, the UCWords will not convert internal characters to lowercase when it's called on an all uppercase value, which is why on line 85 and 86, the 2 values for title and director were converted to all lowercase with a string to lower call, and that passed to the UCWords function to convert the first letter of each word to uppercase. That's a little quirk, and often when we encounter little quirks in library functions, we need to work around them, and this is one of those workarounds. On line 25, we use a for each loop to iterate over the data stored in our movie catalog. This is possible because we implemented the iterator aggregate interface for that class. This allows the class to act as if it was iterable. And it is iterable because the class knows how to iterate over the data it contains. So as we move through each of the movie objects stored in the array contained in the movie catalog class, we're simply calling the display function for each of the movie objects. The movie objects know how to display themselves. That's part of the interface we defined for that class. Then on line 33, we're taking advantage of the implementation of the array access interface that allows us to access our movie catalog object using array syntax. Notice that movies, the variable movies, which is an object of type movie catalog, is being treated as if it were an array by using the brackets and an index. Again, because of the array access interface, our movie catalog object knows how to iterate over the elements in the array by index value. And when we do that, each element stored at an index in that array is of type movie. The movie objects have a function called display. So let's see how this runs. The first 3 lines is the output from the file, class, and method magic constants within the debug if statement in the constructor. Then, using the for each loop, we output the 4 movies that we inserted into our movie catalog. Below the marking line, we have the output from the for loop using the array syntax to iterate over the contents of the movie catalog. This example demonstrates how a class implementing a set of interfaces can provide significant functionality for the class, making the class very flexible for the user. This example also demonstrates how we can leverage code within the class to provide functionality in other functions of the class. For example, on line 60, we call the offset set function of the movie catalog class to assign a value to the array. On top of that, we call this class's count function to get the current index of the array at which to insert the new value. So we're leveraging code that we have already written to provide even more functionality to the class.